Hello, my name is Aruna Chandran, and I'm pleased to welcome you to this course entitled Numeric Estimates in Epidemiology. In this course, we will aim to achieve the following objectives. We will describe numerators in public health data, and then explain denominators in public health data and where this data can be found. We will introduce the calculation of ratios and proportions to describe public health problems, and then the use of rates to describe the burden of an issue in a population. In this section, we will visit numerators in public health data. Numerators are essentially counts. These can be events, both negative events, such as diseases, but also positive events, such as trees planted in a park. There can be a score, such as the score that results from a validated assessment tool, or just the number of people that achieve a particular state. In mathematics, the numerator is the top number in a fraction. For example, 1 out of 2, or 3 out of 4. In public health, we define a numerator as the count of persons with a specific trait or condition, or who use a certain program or intervention. So examples could be how many people are served by a particular substance use intervention program, or how many children suffer from symptoms of post-traumatic stress disorder following exposure to a natural disaster. So why do we care about numerators? We can measure how big of a problem a particular disease is in our community. We can compare our numbers with another population or another area. We can think about how to allocate our limited resources, and we can see changes over time. In this graph, we look at the use of numerators by the United Nations in assessing the world's population and then projecting that number into the future. On this graph, you can see between the years of 1950 and 2017 the actual world population. And then, from 2018 onwards, the prediction of what that population would be given recent trends. That prediction line is the dark red line in the middle of the area. The dashed lines surrounding that prediction line are various levels of uncertainty in these estimates. So where can we get numerator data? Often surveys or registries provide an excellent source of numerators. For example, one might have a disease registry in which a community or a population captures diagnoses of a particular disease and keeps track of those individuals over time. The telephone book also provides an excellent sampling of individuals who live in a community, but of course, to be represented in that sample, you have to have a landline telephone. Other times, we use our own counts. It might be someone's observations or counting of a particular event, or it could be in the context of a formal study. Let's take a moment to do a brief exercise. Think about how many small dots are represented in this slide. Now, at face value, this looks like an extremely easy question that a small child should be able to answer. But when we actually think about it, what do we mean by small? Is it any dot that is smaller than the largest dot on this page? Or is it the very smallest dots that we see? You can imagine that two people could use equally sound reasoning to come up with two different answers. And this brings us to the very important concept of a case definition. We need to clearly define who or what gets counted into a numerator, what or who is included, and equally as important, what or who is excluded. The examples we use in thinking about case definitions most commonly come from outbreak settings. For example, if we are looking at cases of watery diarrhea, we might define it as having more than 3 watery, non-bloody stools per day. Or if we are looking at cases of lower respiratory infection, we might define it as having fever, cough, and rapid breathing as defined by greater than 50 breaths per minute. These very specific case definitions allow us to be clear about who we are counting in our numerator. So what is the utility of a clear case definition? As mentioned, it helps you decide who to count in your numerator. It also allows you to differentiate people who might have similar but not exactly the same symptoms. As an example, let's say we are considering the number of students that are enrolled in this course. We might exclude someone who is working on something else while this lecture plays in the background, or we might exclude people who do not listen to the full lecture series. In thinking about numerators, as long as we are clear about who and what we are counting, when and how, we can get a clear picture of a particular disease or event in a population.